So you've got an Apache Spark interview coming up, right? And it feels like you've got to memorize this giant dictionary of terms, doesn't it? Well, what if I told you there's a much simpler way to think about it? We're going to break down a simple framework that'll help you swap that interview anxiety for some serious confidence. I mean, you've seen those lists, right? The ones that go on forever. 15, 20 questions. What's an RDD? Hey, explain the Catalyst Optimizer. Compare all the different join strategies. It's just a mountain of information to try and conquer. All right, here's the secret. It's not about memorizing a dozen different answers. It's really about understanding the core ideas that tie everything together. So we're going to structure all of this around just three, count them, three core pillars. You master these three things, and I'm telling you, you'll be able to handle pretty much any question that comes your way. So here's our game plan. First up, we'll tackle the basic building blocks. Then we'll get into the engine's logic, how Spark actually thinks. Pillar 3 is all about the need for speed, optimization. And finally, we'll wrap it all up with a killer strategy for your answers. Sound good? Let's do this. All right, pillar number 1. This is all about what I call the nouns of Spark. Think of these as the fundamental pieces, the core components and data structures that everything else is built on top of. You get these right, and your foundation is rock solid. Okay, so let's start with a big one. RDDs, data frames, and data sets. The key thing to understand here is the trade-off. On one side, you've got RDDs, resilient distributed data sets. Now, these were the OGs of Spark. They give you a ton of low-level control, which is powerful. But honestly, for most of what you'll do today, the real magic is with data frames and data sets. Why? Because they know the structure of your data. That allows Spark's brain, the Catalyst Optimizer, to work its magic. And data sets, they take it a step further and add what's called type safety to catch your mistakes before you even run the code. Super useful. So how does a Spark job actually, run? It's basically a classic master worker setup. You have the driver, think of it as the project manager, the brain of the whole operation. It figures out the plan. Then it sends out tasks to the executors. The executors are the workers out on the cluster nodes, the ones actually crunching the numbers and storing the data. Okay, that brings us to pillar number 2. So if pillar 1 was all about the nouns, pillar 2 is all about the verbs. We're talking about the logic, the actions, the processes that make Spark so incredibly powerful and fast. This is where we get inside Spark's head and see how it thinks. And one of the first things you have to understand is this concept lazy evaluation. Honestly, it's one of Spark's biggest superpowers. I love this analogy. Think of your Spark code as a recipe. Spark doesn't start cooking the minute you tell it the first ingredient. No way. It reads the entire recipe first, from start to finish. It looks for ways to be more efficient, maybe chop the onions while the water boils. It only actually starts cooking when you say, hey, I'd like to eat now. That waiting is what allows it to perform these massive behind-the-scenes optimizations. And that whole recipe idea leads us right here to transformations versus actions. Your transformations, things like map or filter, they're just these steps in the recipe. They build up this logical plan, which is called a directed acyclic graph, or DAG. But here's the key. Nothing, and I mean nothing, actually happens yet. It's the actions that pull the trigger. When you call something like count or collect, that's you telling Spark, okay, recipe's done, go ahead and cook, I want my result now. And this right here, this visualizes that entire flow perfectly. So you write your code, Spark turns it into a logical plan. Then, the real genius, the Catalyst Optimizer, jumps in and rearranges that plan to make it way more efficient. That optimized plan becomes the physical plan. That's your DAG, and that is what finally gets broken up into little tasks and sent out to the executors on the cluster. Now, even within those transformations, there's a huge difference you need to know about. You've got narrow transformations, which are super fast. Why? Because all the data needed to compute a result is already sitting in one partition. No need to talk to anyone else. But then you have wide transformations. Think group by key or a big join. These are slow. They require what's called a shuffle. Data has to be physically moved, sorted, and reorganized all across the network between the different machines. And you've got to remember this. The shuffle is one of the single most expensive performance-killing operations you can do in Spark. And that conversation about the shuffle brings us perfectly to our third and final pillar, the need for speed. Look, knowing the theory is one thing, but what interviewers really want to know is, can you make a slow job run fast? This is all about practical, real-world optimization. Okay, a classic optimization question revolves around managing partitions. Let's talk repartition versus coalesce. Here's the rule of thumb. If you just need to decrease the number of partitions, you almost always want to use coalesce. It's way more efficient because it avoids that big, expensive, full data shuffle we just talked about. Repartition can go both ways, increase or decrease, but it always triggers a full shuffle. So if you don't need to increase partitions, stick with coalesce. Knowing which to use when is a big deal. Speaking of performance, knowing your join strategies is non-negotiable. It's absolutely critical, and it pretty much boils down to the size of your tables. If you have one giant table and one tiny table, really small, a broadcast hash join is your golden ticket. It avoids shuffling the huge table, which is a massive win. Now, if you're joining two big tables, Spark's going to default to something called a shuffle sort merge join. And that broadcast join we just mentioned? Well, it's powered by this cool feature called broadcast variables. Basically, it's a super efficient way to take a small read-only variable from your driver node and just blast a copy of it out to every single executor on the cluster. It completely avoids sending that data over and over again. It's a classic optimization trick that shows you really understand how to cut down on unnecessary data movement. All right, so you've got the knowledge now. You understand the three pillars. But how do you actually use this in an interview? How do you package it all up? Let's talk strategy, moving from what you know to how you prove it. So when you're asked a question, don't just give a dry definition. You've got to bring it to life. Give a little code example if you can. Always, and I mean always, talk about the performance side of things. How does this make things faster or slower? Even better, connect it to a real-world problem you've faced. And here's a pro tip. Casually mention checking the Spark UI to debug something. That immediately tells the interviewer you've actually been in the trenches, tuning and fixing real jobs. Because at the end of the day, an interview isn't some closed-book memory test. It's your chance to show them how you think, to prove you have a solid mental model for distributed computing, that you understand the trade-offs, the performance implications, that you get the why behind the technology, not just the what. So, before you walk into that room, just ask yourself, which of these core principles will you use to frame your next answer?